Hi everyone and welcome back to Amazing Sharks. Today we are learning about the salmon shark. This is a species of mackerel shark found in the northern Pacific Ocean. Similar to other mackerel sharks, salmon sharks have a thinniform body type. As an apex predator, the salmon shark feeds on salmon, squid, sablefish, birds, walleye, pollock, and herring. Salmon sharks get their name from their diet, which primarily consists of salmon. It is known for its ability to maintain stomach temperature, which is unusual among fish. The shark has not been demonstrated to maintain a constant body temperature. It is also known for an unexplained variability in the sex ratio between the eastern and western populations in the northern Pacific. Now, if you look at the videos of the salmon shark, you'll see that they look like little miniature great whites, which is why the salmon shark is one of the most well-known smaller sharks of the ocean. Let's look at them. They got the little great white body, the same coloration and everything. A lot of people think that they're actually related in some way because of this, but DNA tests have not quite been done on that. We do know that they are a mackerel shark, which is similar to a great white shark's family type. They're very close relatives, at least. But they are very cute little sharks. I've always thought it would be cute to have one in like an aquarium or something. All right, let's learn some more about these salmon sharks. Adult salmon sharks are medium gray to black over most of its body, with a white underside with darker blotches. Juveniles are similar in appearance but generally lack blotches. The snout is short and cone-shaped, and the overall appearance is similar to a small gray white shark. The eyes are positioned well forward, enabling binocular vision to accurately locate prey. The salmon shark generally grows between 6.6 to 8.6 feet in length and weighs up to 485 pounds. Males appear to reach a maximum size slightly smaller than females. Unconfirmed reports exist of salmon sharks reaching as much as 14.2 feet. However, the largest confirmed reports indicate maximum total length of about 10 feet. The claims of maximum reported weight over 992 pounds are unsubstantiated. Salmon sharks have a wide double-keeled tail, a second short ridge that runs along the upper part of the lower lobe of the tail. The only other shark with a double-keeled tail is the porbeagle shark, which the salmon shark is closely related to. Salmon sharks are voracious group hunters. Groups of 30 to 40 individuals have been spotted hunting salmon in Alaska. Salmon sharks can also hunt alone. However, individuals congregate in large groups in coastal waters to hunt bony fish such as salmon. Studies on prey consumption show that salmon sharks have similar energetic requirements as sea lions and other piscivorous marine animals. The salmon shark is oviviparous, birthing a litter of 2 to 6 pups. As with other laniform shark species, the salmon shark is also euphagous, with embryos feeding on the ova produced by the mother. Females reach sexual maturity from 8 to 10 years. Males generally mature by age 5. Reproductive timing is not well understood, but it is believed the sharks are on a 2-year cycle, with mating occurring in late summer to early autumn. Gestation is around 9 months. Some reports indicate the sex ratio at birth may be 2 to 2 males to females, but the prevalence of this is not known. Once salmon sharks are born, they are completely independent. Pups are spawned along Baja California. As with only a few other species of fish, salmon sharks have the ability to regulate their body temperature. This is accomplished by vascular countercurrent heat exchangers known as retia mirabilia, Latin word for wonderful nets. Arteries and veins are in extremely close proximity to each other, resulting in heat exchange. Cold blood coming from the gills to the body is warmed by blood coming from the body. This results in the blood coming from the body losing its heat temperature so that no heat is lost, losing its heat so that by the time it interacts with cold water from the gills, it is about the same temperature, so no heat is lost from body to the water. Blood coming towards the body regains the heat, allowing the shark to maintain its body temperature. This minimizes heat loss to the environment, allowing salmon sharks to thrive in cold waters. Past studies have shown the average surface body temperature for a salmon shark is around 8 degrees Celsius, while the internal average body temperature was around 16 to 19 degrees Celsius relative to other sharks. Their hemothermy may also rely on SIRCR2 and iodine receptor 2 protein expression, which may have cardioprotective effect. North of the equator in the northern Pacific Ocean, the salmon shark is relatively common in continental offshore waters where it ranges from inshore to just off the coast. Tagging has revealed a range which includes subarctic to subtropical waters. The species is believed to range as far south as the Sea of Japan and as far north as 65 degrees north in Alaska, notably appearing en masse in Prince William Sound during the annual salmon run. Individuals have been observed diving as deep as 2,192 feet, but they are believed to spend most of their time in pelagic waters. While salmon sharks primarily travel alone or in feeding aggregations of several individuals, sometimes they may be seen in schools. According to a study in 2008, salmon sharks have been observed to use area restricted search behaviors in both southern and northern Pacific Ocean regions. That migrate through southern high productivity regions exhibit more of these behaviors than those who travel along through low productivity regions. Salmon sharks travel fast during migratory patterns. Studies conducted on said migrations put the average speed of the individual sharks at 33 kilometers. The juvenile salmon sharks stick to the more coastal regions along the western coast of North America. Juveniles prefer water temperatures between 12 and 16 degrees Celsius. Juveniles prey on a variety of mesopelagic, intermediate depth, and epipelagic, the upper layer of water column where light penetrates for photosynthesis, offshore prey. Age and sex composition differences have been observed between populations in the eastern and western northern Pacific. Eastern populations are dominated by females, while the western populations are predominantly male. Whether this distinction stemmed from genetically distinct stocks or if the segregation occurs as part of their growth and development is not known. The population differences may be a result of Japanese fishermen harvesting more of the male population. Certain Japanese herbalists use salmon shark fins of males specifically in some traditional soups and medicines said to treat various forms of cancer. Currently, no commercial fishery for salmon sharks exists, but they are occasionally caught as bycatch in commercial salmon gill net fisheries, where they are usually discarded. Commercial fisheries regard salmon sharks as nuisances since they can damage fishing gear and consume portions of the commercial fish. Fishermen deliberately injuring salmon sharks have been reported. Sport fishermen fish for salmon sharks in Alaska. Alaska fishing regulations limit the catch of salmon sharks to two per person per year. Sport fishermen are allowed one salmon shark per day from April 1st and ending the following March 31st in British Columbia. The flesh of the fish is used for human consumption, and in Japanese city of Kasunuma, Miyagi, the heart is considered a delicacy for use in sashimi. Although salmon sharks are thought to be capable of injuring humans, few, if any, attacks on humans have been reported. But reports of divers encountering salmon sharks and salmon sharks bumping fishing vessels have been given. These reports, however, may need positive identification of the shark species involved. Salmon sharks have never been positively identified attacking humans, and there is no confirmed evidence that salmon sharks have attacked humans. Declines in the abundance of economically important Chinook salmon in the early 2000s may be attributed to increased predation by salmon sharks based on remote temperature readings from tagged salmon that indicate they have been swallowed by sharks. Similar to white sharks, salmon sharks have a slow growth and reproduction rate, making them susceptible to overfishing and overexploitation. They are considered least concern, however, juvenile salmon sharks are extremely susceptible to temperature changes in coastal waters. This means that further ocean warming can severely impact the species. There are reports of declines in salmon shark populations from Alaskan fishermen. And that, my friends, is the salmon shark. Next up, we will be doing the porbeagle shark. All right, you guys, don't forget to like, comment, and subscribe if you enjoy my videos. I have done many, many shark videos so far. I think this is the 22nd one. So I hope you guys are really enjoying. And there is a piece of newsreel I wanted to read to you about the salmon shark, which is what inspired me to do this video in the first place. So give me one moment. All right. So, what I wanted to read you about salmon sharks is this article on Forbes magazine about how they help us understand climate change. Since the early 2000s, the amount of ocean data collected has surged, providing scientists with critical insights into climate change and ocean variability. This increase is largely thanks to the deployment of thousands of Argo floats, which now cover oceans globally. These robotic sensors have provided over 2 million temperature salinity profiles, yet gaps remain, particularly in remote areas like polar and coastal regions. To fully understand the changing oceans, scientists need more data from these undersampled locations. The Gulf of Alaska is one such region where climate change is expected to have pronounced effects. While traditional monitoring tools are useful, they can't be used everywhere at once. This is where the marine life comes in. Elephant seals have been fitted with tags that measure temperature, salinity, and depth, helping us to fill these observational gaps in hard to reach waters. Since 2002, data from tagged seals has transformed our understanding of ocean currents, sea ice formation, and subscale processes. Small but crucial movements of water that influence larger climate patterns. Now, researchers are expanding this concept to sharks. Large, non air breathing marine animals such as salmon sharks are frequently tagged with satellite transmitters that record depth, temperature, and movement. These sharks dive deep and travel far, making them ideal for collecting oceanographic data in regions where other tools fall short. A new custom built tag called CTD-SRDL was designed to fit on the salmon shark's dorsal fin, allowing researchers to track temperature and salinity profiles while following the shark's natural movements. In 2015, a 5-foot long salmon shark was tagged in Port Gravina, Alaska, with one of these devices, and for over 36 days, the shark traveled more than 840 miles, transmitting 56 detailed temperature salinity profiles via satellite. The shark's journey provided a unique opportunity to examine ocean conditions during a particularly significant event, the blob. The massive patch of unusually warm water appeared in the Northeast Pacific in late 2013 and lasted until 2016, causing widespread disruptions to marine ecosystems. The data collected from the tagged shark confirmed that most of the water it traveled through was warmer than average. Nearly 75% of the temperature readings showed positive anomalies, with some areas registering more than 3 degrees Fahrenheit above normal. These warm anomalies were mostly pronounced at depths of around 65 feet, especially off the coast of Sitka, Alaska. However, the shark also encountered pockets of colder water, typically closer to the coast and in deeper layers. Salinity measurements were more variable, with some areas showing saltier than average conditions while others were fresher. Interestingly enough, the strongest fish anomalies were recorded in the northern section of the shark's journey, while saltier more waters dominated farther south. One of the most intriguing finds came from the shark's encounters with mesoscale eddies, large rotating bodies of water that can influence ocean circulation and heat distribution. Over its journey, the shark moved through 7 of these eddies, capturing detailed profiles of their temperature and salinity structures. Some eddies trapped warmer, saltier water near the surface, while others had pockets of cold, fresh water at different depths. These observations, the scientists say in their publication, allows for a better understanding on how heat and salinity move through the ocean, influencing larger climate patterns. The data collected from the shark was then compared to information from Argo flows in the same region, and while both sources provided valuable insights, it turns out that the shark's data had a much higher resolution in certain areas, especially in dynamic regions influenced by eddies and coastline interactions. If all salmon sharks tagged in the Gulf of Alaska over the past 17 years have been equipped with these special CTD tags, the team estimates that the number of high-resolution ocean profiles from this region would have been significantly higher, providing a much clearer picture of ocean conditions. Yep, that's right, you guys. We can hire sharks now. And I'm sure they'll be happy to take their payment in fish, right? Anyways, I hope you enjoyed that article. I really enjoyed reading about it because it shows just how important these rare, hard to find sharks are. And even the not so rare ones can be super important to our oceans. So, next week, you guys, poor beagle sharks.